everyone, it's Judy Warner. Welcome back to this week's Ecosystem Podcast. Today, I'm joined by Roberto Piacentini of Keysight. We're going to dig into what is driving the velocity of innovation, how that's going to impact design engineers like you, and give you some ideas, tips, tricks, and trends that I think will help you stay ahead of the curve and thrive as an engineer in these exciting times. Now let's jump into our conversation with Roberto of Keysight. Hi, Roberto. Thanks so much for joining us again today. I'm excited to talk about what's driving this crazy velocity of innovation we're seeing across the industry.
Yes, thank you for having me. I'm excited to be here with you so we can talk about the velocity of innovation and how it relates to the design engineering workload.
Well, that's exactly what I'm curious about because I'm listening to people who have been experts in the industry for decades telling me they've never seen anything like they're seeing now. The speed at which we're stepping up, speed curve or complexity curve or power curve or thermal curve. And I'm just wondering how the people in our audience are keeping up. And I know you have so many insights there. So I'm looking forward to this. So let's talk about, of course, AI is the elephant in the room. So we can just assume right off the bat that AI and the data center and infrastructure to support that is certainly driving a lot of this. But are there other things that are driving this crazy pace of innovation we're seeing?
This is a really good question to get us started, Judy, because you really got a good point there, which is from time to time we do have some of this major technology trends coming up. Like a couple of years ago, we had chiplets, right? Which wasn't
Uh-huh.
a really new technology, but it was a new way of using chiplet to fuel innovation in some other areas. Then came up AI. So then now I have AI. AI is everywhere. We have all sorts of AI applications bubbling up, not just in commercial applications such as design, but also in consumer applications like the Alexas and Google Assistants of the world. So those technology trends, they certainly help fuel innovation and also get people excited about innovating and leveraging those new technologies. However, I think that there is another aspect that we don't talk very often that really keeps fueling innovation, and now more than ever, which is the tools that the designers they use to create such innovations. I if you look at some of the tools you use today for EDA, for example, and you compare it to the same tools about 5 years ago, it's a completely new beast. The
Mm-hmm.
tools have evolved tremendously, and one of the good side effects, I guess, of the tools evolving is that it's more accessible than ever. So we are really helping the designers to focus on what they do best, which is design the electronic designs, debug problems in their designs in there. But like I said,
Simulate.
it's really
Yeah.
accessible. It's really accessible nowadays.
I'm seeing that. That really rings true. I did a series not too long ago about AI tools, specifically around EDA, PCB layout, managing supply chain. One of our sponsors, Cofactor, is doing amazing things um, to make the supply chain management, like, really bring it into the century. So that rings true to me from conversations I've had really across the whole ecosystem.
Yeah, and there's one thing that I was going to say that is interesting here is that the one of the results of technology being so accessible is that innovation is cheap. So then
Mm,
nowadays, engineers they can like things with digital twins, virtual prototyping. It's cheap for them to put something together really quick and kill the bad ideas really fast with better ones. So
mm,
the technology, the
right.
EDA tools evolving, and the tools that designers have available to them today, being so accessible makes it cheap for them to innovate. So that's why we're seeing this explosion of innovation everywhere.
It makes a lot of sense because, as you know, in the olden days, you would design a product, go build a physical
Yeah.
prototype, put chips on it, and you'd have to throw the stuff away. Some of it you could, pull off the board or whatever, but now you can do that. I like your colleague Tim Wangley. He calls it the digital sandbox, right? You can you can try a lot of things very easily and quickly
Exactly.
without having to stand up, and it's obviously way cheaper, way faster. So, yeah, that makes a lot of, sense to me, and as you said, I am seeing that, um, lots of different tool companies across the industry are coming at it slightly different angles, but everybody seems like they're trying to break this nut of having giving visibility, across the whole end-to-end design, and nobody, as far as I know, does it better than you guys. So how do you think this is going to impact the design engineer over the next, say, 3 to 5 years, and maybe the way they design, their workflow? Are they gonna use different tools? Like, what do you see on the horizon?
Yeah, I think this all depends on how well two vendors like Keysight will respond and listen to their customer needs. As innovation is bubbling up, we are hearing people they want tools to be easier to use, simpler, more connected, that fosters collaboration. So it's important for us suppliers to listen to these requests and get the right tools for the right jobs. So then, as I said, I think it depends on how well the suppliers of such tools will respond, addressing all of the facets of the industry and how fast it's moving. I mentioned collaboration, and to be more specific, give you a more specific example here. Think about the design workflow and the how much data is generated for any design, from the simplest to the complex. You'll have the design files that are very large. You need to understand how your design is being used, especially if you do IP. What are all of the uses that are getting your IP within your company? What are the use cases that are reusing your IP? When you do validation of
Right,
your models, you simulate. So then you have the results data there. You have the actual measurements that you make with instrumentation, and you have to correlate. All of this generates report. So then you have two separate. In the past, you'd have two separate set of tools. You have the EDA tools that actually help do the simulation. You have the hardware instrumentation that help you make the measurements, and then you have Excel, or perhaps you get some other tools there to help you manage your data. So we see a convergence of these tools kind of collaborating together. And I can use the example of Keysight. Keysight, we have the simulation, the Keysight EDA software platform. We have a design data and IP management solution that is very closely tied and connected with our ADS solution for EDA. So then designers, they can have their design files managed by design and data solution. You can check on design data solution where the design is being used. And then you have the Keysight instrumentation also connected with the simulation tools, also connected with design data management tools. So then everything is working together. So we are making the life of the designers easier for them to do what they do best, which is design. They don't want to be managing files, right? They don't want to be having to figure out who changed their files or how their IP has
right.
been reused, right? So then back to my first answer, it depends on how the two suppliers are responding. Uh, Keysight, we are very attentive to the workflow and making sure that the tools that we provide are really talking to each other and helping throughout the flow the engineers and designers. Does it make sense?
It makes perfect sense. I think do you see my devil horns
All
coming up?
right.
I wanna play devil's advocate for a minute because, um, Keysight, when I say nobody does it better than you, it's people like Steve Sandler who says that to me, or Ben Dan, and people that we know that are doing advanced designs. They're the ones that have told me, "You guys do it better than others." So, um but I think, my years at Altium, they were trying to create, this system of APIs embedded. I mean, they're still working on it. And Siemens, of course, bought up Mentor, and they're trying to create this connected workflow. But if I'm the engineer just trying to get my stuff out the door, and one, don't touch my tools. Like,
Yes.
engineers get very attached to their tools, right? But this thing is happening. And my point here is to say there's so many options. If I am an engineer, one, how do you talk me off getting me off tools that I'm really comfortable with? And two, how do I know which one? Because there's lots of people trying it in different ways. And so, anyways, that's me playing
Yeah, no,
devil's
this is
advocate.
this is actually a good
But
point.
I wanna say one more thing, and I've said it before in the podcast. The thing I like, though, is I see companies like Keysight working with Ansys or Altum. You're all starting to collaborate a little bit, which I think helps engineers keep the tools they want to if they
Exactly.
don't want an end and so I
Yeah,
just
no, this
answered
is a
my
good
own
point,
question.
and you mentioned it. Collaboration is a key aspect, right? We have to
Yeah,
collaborate. And EDA tools, it's a mature, and EDA, the design space, is a mature area, right? So then there are excellent tools out there. I'm not naive to say that my tool, Keysight tool, is the only tool that can solve answers. No, there's many really good tools out there as well. But as you mentioned, collaboration is key. So then the players in this space, so then Keysight, Siemens, and everybody, we have to kind of work together to make sure that we keep in focus the end customer, the designer at hand. The other aspect I was
right.
going to mention that is interesting, it puts Keysight in a unique position. If you look at Keysight and our history, all the way back to the Hewlett Packard days, Keysight is almost a centenary company. We have, I mean, experience, I should say. Keysight is a little bit over 10 years old, but our engineers, the people within Keysight, come all the way back to HP. So then we have our beginnings on measurement. So then we understand measurement science really well. So since our very beginnings, Keysight it's embedded with several industry bodies, like for example, UCIe for chiplets, JEDEC for DDR. We have the PCI SIG for PCI, 3GPP for RF. So then Keysight, because we make the instruments, we are embedded in those bodies. So then we get to hear about those
Mm,
things oftentimes earlier and before some of our competitors in there. And because we've been doing this for so long, we have designers within our organization. We try to build, as I mentioned before, this complete ecosystem that that can help the designers to design to the entire workflow from concept to design, simulation, emulation, validation, test, all the way to manufacturing, if you will. You can you we have solutions for on that perspective. But back to your point, yeah, you're right. It's important that we need to have the collaboration. And I'll give you one more example. I know we're talking a lot about data and so forth. It's one of the areas that I'm passionate about is data intelligence flow. You know, if you think about the
yeah,
key, we talk about collaboration, but more specifically to the designer, really what they care is how data flow, right? When I'm designing my new electronic circuit, I want to see, all right, what are the bugs? And this is data. Where the bugs are, this is data. Where's my IPs being used? This is data. How my simulation correlates to the real world, this is data, right? So then the data intelligence flow, it's really important. And we have a tool, the Design Data and IP Management by Keysight, that is not exclusive to Keysight. Our tool talks to Keysight ADS for determined design. It talks to the Cadence platform for EDA. It talks to Siemens EDA. And again, it's us collaborating with each other and putting the designer first on that. So this is what I think it's important. And you nailed it. Collaboration is key in this space.
for sure, and, for our listeners, by the way, I did a very interesting, conversation with, Simon Rance, who came with the CleoSoft,
That's right.
um
CleoSoft.
acquisition. Anyways, I'll for our listeners, I'll put that in the show notes because that does, as Roberto mentioned, work with a lot of different tools, but he does a really good job of articulating data management flow and really how to manage that expertly. And I like what you said. It's sort of like uh, the right tool for the right job, right? And
Exactly.
I also like because I work with engineers so long and they get very attached to certain tools and they drive them really well. And to start all over and to learn a new tool can be daunting or maybe it's not open to them. So I like the idea that if somebody wanted to go end to end in Keysight or Siemens or what they could, but they could also use the best of each one that they're accustomed to using and that works well together.
Yeah.
Um,
And
but that
and
data intelligence is becoming such a huge thing because it actually drives value for your whole business.
exactly. Exactly. And one thing I was going to say, Judy, is that when you have these two things together, like when you bring end-to-end solutions, which is what Keysight has, with high levels of collaboration, there's something I really like to point out, which is concurrent engineering. It's something we didn't talk too much yet, but what it enables when you bring these two things together, an end-to-end tool chain, that has all of this that unlocks this collaboration, you get concurrent engineering, which is you are making a parallel the tasks. You have all these different teams being able to collaborate in parallel. So you are doing serial versus parallel workflows. So then you have the design engineer that is building the schematics and testing for signal integrity, in parallel, you have the power engineer doing power integrity on the same circuit, and the tools talking to each other, the data being logged into the same data management tool, and they can collaborate. They can put comments on the results and add reference. People say, "Hey, Judy, I noticed this on your power integrity. Can you check this really quick?" So then it's all with the data. We're talking about the data intelligence flow. The data intelligence is flowing really fluidly between all these different teams in parallel. And I think this is a really value added to the designers when they can do their job unblocked by these other tasks that are important if you look at the workflow for design, right?
I think I've mentioned this before, but I was talking to Matt Burns at Samtech one time, and he says something that really stuck with me, because they collaborate with chip manufacturers and, they make high-speed flyover cables and all this, but I'm like, "Why are companies that in previous years have not been willing to work together," right? Willing, and he says, "'Cause the speeds are too fast. There's too much data, and the speeds are too fast. It's almost forcing us." And the good thing is there's a benefit, I think, if I hear what you're saying, the benefit is to the designer because, um, not only Keysight with their unique perspective and culture as a company, but these other ones are also leaning into this collaborative, and being able to capture that data is huge
Yeah,
because you're
and you're
not.
talking about data, so I think let's talk really quick about it. I know we talked at the beginning, but let's be clear what we mean by data. This is
Okay.
electrical data. This is mechanical data. This is signal and power integrity. This is EMI. There's actual measurement, physical measurements data in there. And one aspect that we didn't talk too much, but mechanical. I know we're talking about electrical
Uh-huh.
design in here, but think about when you are designing your electronic design in there. You got to do mechanical design as well. You have to design the board mechanically. You have to design the board
Mhm.
for thermal. You have to design the board for durability. And I don't know if you know of our listeners know, but think about Keysight, the end. We talk about end to end, and we try to confine ourselves the end to end into electronic design, just electrical pieces. But we
Uh-huh.
also have a company that we acquired a couple of years ago called ESI, and ESI does what we call computer aided engineering. They do virtual prototyping. So then within the same
Uh-huh.
platform at Keysight, you can actually do this virtual prototyping and figuring out how components will interact in the physical world. Traditionally, ESI is focused more on larger things, like take for example automotive, for example, or aerospace. So then you wanna investigate how a car will perform to crash. So then this type
Right.
of physical simulations, Keysight's also capable of doing the mechanical area. So that we are
Hmm.
expanding beyond just the electrical and
That's
going
interesting.
everything simulation wise. If you the virtual prototyping is it's really, it blows my mind the kind of stuff that we can simulate today and stay within the Keysight family of solutions.
Speaking of which, you touched briefly on automotive, and
Yeah.
when it comes to things that's driving this innovation, I think of how much electronics are in automotive
Oh
and
yeah.
how much power, heat,
Exactly.
temperature swing, sensors, cameras, talk
Yeah.
about data.
Yes.
And
Exactly.
so that's gotta be driving a lot of this velocity of innovation too, because 'cause we're marching quickly towards autonomous driving.
Exactly. And you know what? And the automotive, I think it's a really good example to illustrate to your listeners in here, which is, think a car today is a computer on wheels. And is a computer on wheels that make calls. So it's becoming everything. So think about of an end-to-end workflow. We were talking about only the design of electronics, but automotive. So then somebody needs to design the aerodynamics of the vehicle, right? And this is the computer aided engineering. Keysight through ESI,
Mm,
we have simulation in there. once they actually design the vehicle. And this goes for crash test. They can actually go and simulate the lighting inside the vehicle if they want to see how lighting
Mm,
are inside when you do lighting. You've seen in cars today, they have lots of LEDs and ambient lighting. It looks like a, back in my days, I'm not that old, but disco type of things. It's awesome. You can make all sorts of colors inside. So you can simulate the lights. You can actually simulate. I mentioned the crash. You can simulate the lights. You can simulate, and this is something I didn't know. Even the seats. Did you know that the seats of the vehicle, the companies, they simulate it. Like they simulate, meaning they build the seat virtually. They select which materials are going to go into those seats. They
huh,
actually simulate the weight of the person. They simulate the temperatures that the seat's going to take, depending how long somebody sits on that. So then they simulate the seat, and then they simulate the sound system of the vehicle. And all of this is even before getting into the electronics. You talked
right.
autonomous vehicles, and then you have the ADAS systems, the driver supporting systems there. You have radar. So then you got to have RF simulation. You got to have RF measurements to validate the simulations with the measurements. You got to have, there's a network inside, all these different sensors talking to each other, to the main computer. There's electronic design. There are chiplets in it. There are PCIe, there's DDR, there's memory. So then think about everything that goes in there. And Keysight literally has a simulation or measurement solution for all of the stuff that you're talking about, from the concept to the mechanical design, electrical design, thermal design, lighting design, even, like training, when you are training the people in your manufacturing plant and you're going to train them on the engine, where to put the pieces of the engine or where to mount a door or something. The ESI solutions can even help them see in a virtual environment how the door attaches to the vehicle, and when you're designing, for example, a change on the physical size of the door or vehicles, they can see how the change will fit or not fit the physical design in a virtual environment first. So talk about end to end. So this is an awesome example
Yeah.
from
I had no
electrical to
idea you
mechanical,
guys had
all of that.
gone
Yeah.
it.
And then you
I had
throw in
no
there the
idea
data
you guys
management. I forgot the data management. And then you have
yes.
the data and IP management solution. They help you manage data that is produced throughout of that. So you asked about what Keyset has to offer. Well, I guess this is a good chunk of tools on our belt to help designers to really unlock the data intelligence flow and work in any direction in virtual and in parallel design flows, the
Mhm.
concurrent engineering piece that I talked about. So anyway, it's amazing. I'm so excited.
I can tell how passionate and excited you are to see all the things you're seeing there at Keysight. I really had no idea you guys had dipped your toes into the mechanical side,
We did. We
um,
do. Yeah.
which is really interesting. And well, I always leave conversations like this when Roberto feeling a little overwhelmed. Hopefully, it's just me because there's so much to pay attention to and how to do it on a day to day for engineers that are in our audience, no matter what they're building, from something very simple to something as complex as a car, and owning your little piece of that design and how to collaborate with your team. So, uh, do you have any sort of actionable tips that you might give to engineers over the next 3 to 5 years that they can just start thinking about or marching towards or getting educated on or learning that, as you see the future barreling towards us,
Yeah.
that might help them just
Yes.
thrive and do better and prepare
Exactly.
for
Exactly.
what's
I think
coming?
this is a really good comment and a really good closing summation of everything we talked about here. So the main tip I give here is that technology is more accessible than ever, and innovation is cheap. So whenever you are selecting tools, whatever the vendor is, always look how data flows on that selected tool that you pick. Data intelligence is really what's going to drive the efficiency and productivity of your work. So, sure, we have to look at the tools from a technology perspective if it meets our requirements. For example, if you're designing chiplets, yeah, sure, you have to support UCIe. Keysight has Chiplet 5 Designer, supports the UCIe, supports bunch of wire. Check the data sheet of the products. Next, take a look at how that specific solution integrates with your existing workflow. How does it augment the data flow, the data intelligence flow, how the insights are flowing from the tool across your workflow. If there's gaps, if there is roadblocks, maybe it's time for you to consider another tool, a tool that really unlocks that. Because in today's world, speed is really fast. We cannot afford using the wrong tools for the job. Like we cannot use Excel nowadays. Excel is a great tool, by the way. Don't get me wrong. I love Excel.
Yeah,
Um,
I know.
but it's the right tool for the right job, right? I can use Excel to manage all of the design data aspects, sure, but you might spend a lot of your time managing spreadsheet files and really not focusing on the core of your job, which is designing electronics, finding bugs, fine tuning signal integrity. So to summarize, I think you focus first, the data sheet of the product meets your needs. Second, make sure that you make a requirement that the data flows consistently and the data flows aligned with your workflow. Think first, data intelligence flow. How does it flow? Is it helping you do your job faster or not? If not, maybe it's time to check for another tool.
And making sure that your upstream and downstream stakeholders can see it too,
Yeah,
so they
exactly.
don't make assumptions, right? They
Exactly.
can
Exactly.
see in both directions what's happening, so you have kind of
Yeah.
situational awareness
Yeah.
of what's happening in the total system, which
Exactly. And
has
you know
always
what?
been a
And one of the
problem
things I was
too.
going to say, Jude, is that oftentimes we are humans. We don't like change, right? So oftentimes we continue doing things a certain way just because we had always done that. So another tip is take leverage that right now technology and innovation is cheap. So take this into account and then take this time to really consider if the tools that you have are they really helping you out? Is there something else out there? You know, and not always judge the tools per price. Judge the tools for how much they're going to help you. Because I think from a price perspective, all tools are very similarly priced. So I don't think
Mhm.
today it's is a good thing. So to use as a differentiator, or by differentiator I mean whenever you pick something, don't put price in there because everybody is reasonably the same price. So this is
Right.
my tips. I think those are how
I
today
think
I
they're
would
good.
use to pick my tools.
It's more what you're saying is more about mindset and
Exactly. Yes. Yeah.
thinking
Yeah.
proactively instead of
Exactly. Yeah.
reacting all the time.
Yeah.
We have to get out of that reactive cycle, and we've got the tools. We don't have to do it
Exactly.
anymore. So I think that's a good tip. So, final word. What do you overall like? What do you think 5 years from now we'll look back and say about this particular, say, tipping point in the industry? You know, what's inspiring or good about the times that we're on?
Yes. All right. So then, besides we in 5 years been sitting sipping margaritas in the beach, I guess I'll put it aside. So then, I do think that AI is going to play a key role in the design space. So then we're going to see the more and more the birth of AI assisted electronic design automation. Keysight just released a couple of months ago our first set of tools with AI assisted EDA for our RF products for simulation. So this is something for your listeners to check out as well. So AI is, we're gonna look back, say, hey, you know what? How could we live? Look how much time we wasted in the past, and now in 5 years in the future, how much time we are saving sipping margaritas on the beach because AI is helping me do my job. So AI is really going to help us
Well,
out, and I don't fear AI because I don't think that AI will ever replace humans. AI is going to really help us do our job in a much faster way. So then again, this really excites me. It's a really exciting time to see how innovation is cheap, how AI is boosting productivity, how the companies are more friendly than ever to each other, collaborating, the tools talking to each other. So in 5 years from now, we're going to see a really really fun. Right now is already fun, but 5 years from now, we're going to look back and look how could we live without AI assisted solutions in our tools.
that's that's good words, and, to resonate with what you just said, I heard something that I really liked because, as you mentioned, a lot of people are scared that AI is gonna take jobs, but of all the AI tool people that I'm talking to, they're all design assisted because you need the human intelligence complexity and all of that, but, someone said, "AI is not gonna take your job, it's gonna take your tasks,"
Exactly.
and
It's a really good way to
I
put
l
it.
I really like that. It's gonna offload some of the menial, time-sucking, if I can say that, task off your plate so you can be more productive and do the creative, interesting things that make us uniquely human.
Exactly.
So
This is great.
good. Well, thank you for all of that. It's been really interesting seeing through your eyes. Thank you for joining us. Is there anything you'd like for our listeners to go check out, look into? I know you have an amazing educational platform called Keysight Learn. Is there anything you'd like to share with our audience before I let you go?
Yes, absolutely. So then we just released two new learned technology pages that I'm going to share with you all. One dedicated for RF and another one for high speed digital. So it is a compendium of resources that includes all sorts of technologies like chiplet, DDR, satellite, non-terrestrial communications, microwave, you name it. There's AI in both of this. So then it is a really interesting place where your listeners can really dive into key trends, key topics, and then see what is shaking the design space for RF, high speed digital, but through a lenses more around the technologies, like I mentioned, PCIe, triplet DDR, non-terrestrial networks, that kind of stuff. And we'll share with you guys. Those are two learn links that has videos as well. There's some courses. And one thing I was going to say, just to kind of plant the seed, we have something I'm going to say now. It's not ready yet, but we have a masterclass coming out with Eric Bogdan that Judy helped us out, the ecosystem helped us out, put together. It's a joint project. I'm so excited about it. It is really a masterclass that talks about S parameter analysis. So this is something else that is coming out, and we'll update this blog with the links so then you all can have it. So I just thought about mentioning it.
Thank you. I wanted to, but I didn't want to say it without your permission. So thanks for plugging that. And for our listeners, as soon as I have that link, I'll throw it in the show notes of this podcast. But we'll be back with Eric to talk a little bit more
Right.
about reading S parameters like a book.
All right.
And so okay, well, I'll get all those things from you, Roberto. Thank you again. I so value our partnership and for Keysight and you being always willing to share your perspective and everything you're seeing that's happening across the industry and giving our audience insights to what's going on and how they could do their job better. Thank you so much.
All right. Thank you.
To our listeners, make sure you go check out those show notes, like, subscribe, do all the usual stuff I asked you to do. We'll see you next week. Until then, remember to always stay connected to the ecosystem.